students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the numerical problems on EMF of the cell. So the first one, predict whether to any extent oxygen will oxidize chloride to chlorine. So oxygen has to oxidize chloride ions to chlorine. Chlorine in bracket G means gas. So where is it happening? It is happening in the presence of acidic solution. So acidic pH. So the reactions are given like this. The oxygen in the presence of acidic, like proton are high in concentration, that will receive 4 electrons and forms water. So it is giving rise to water, and it has a potential, electrode potential of plus 1.23 volt. 1.23 volt. So next, the other reaction is given, like chlorine is converting to chloride. But what is happening? What is it asking here? The chloride has to convert to chlorine. Chloride ions should convert to chlorine. So that is the reaction we need to take into consideration. So here what happens, whenever chloride is converting to chlorine, that is in the, like oxygen will be oxidizing this chloride to chlorine gas. So that is happening in the presence of acidic medium. So then there is the chloride-chlorine electrode, wherever the reaction is taking place, that will act as anode because oxidation is taking place. Here, oxidation reaction is taking place from -1 to 0 state. It means increase in oxidation state. So, oxidation reaction is taking place and it forms the anode. And what happens with the cathode, like water, oxygen in the presence of H plus ions, it is converting to water. So here it is converting to water. So converting to water is like reduction, it is happening. So therefore it is the cathode. Now we have understood what is cathode and what is anode. So what are the potentials for cathode? For cathode, what are the potentials we have? Plus 1.23 volt, and for anode it is plus 1.36 volt. So these are the values we have, and now we have to predict whether this reaction will happen or not. So to understand this, like it is different from the metallic reactions that are going on, like metallic salts from the metallic ions. So we have to now calculate the EMF. So upon a calculation of EMF data will give us the spontaneity of the reaction. So depending on the spontaneity, we will know the feasibility of that particular reaction. Nothing but whether the reaction will take place or not. So let us find out the EMF now. So E cell is given as E cathode minus E anode. So we are substituting the values. E cathode plus 1.23 minus of plus 1.36 for the anode value. So we will get minus 0.13 volt. Whenever there is a negative sign, it indicates non-spontaneous reaction and the reaction is not feasible. So the question they are asking is whether predict whether to any extent oxygen will oxidize chloride ions to chlorine. It means it cannot do. So it is not feasible. It is not feasible because it is negative. The E cell is the negative in nature, so it is non-spontaneous reaction. The push is low, so therefore there is no reaction taking place and it cannot oxidize the chloride ions to chlorine. So next is the similar one, the other example, like we have predict whether to any extent, significant extent, iodine will displace. So here displacement reaction they are asking for. Displacement, depending on the electrode potentials, displacement reactions are also defined. So whether iodine will displace bromide ions to produce bromine. So what is happening here? The bromide ions minus state is converting to bromine ions. So what did they give? They give us the electrode potentials for bromine reduction, like it is converting to bromide ions and it is having an electrode potential plus 1.07 volt, and the iodine is converting to iodide and it is having plus 0.54 volt. These are the data they have given. So iodine has to be oxidized. So iodine has to oxidize these bromide ions to bromine. They are asking us whether iodine can displace bromide ions. So it has to oxidize bromide ions to convert to bromine, that is in liquid. So if you see, bromine is always in the liquid state. So then the bromide-bromine electrode. So the reaction, wherever this reaction is taking place, it will act as anode. So this is forming anode, and the iodide and iodine electrode will be the cathode. So this is the cathode. So what are the values for cathode now? Cathode is equal to plus 0.54 volt and anode is equal to plus 1.07 volt. These are the values we have. Now we have to calculate the E cell, that is equal to E cathode minus E anode. So on substitution we get plus 0.54 minus of plus 1.07 and we get minus 0.54 volt. So this is also in negative. So whenever there is a negative indication, it indicates that non-spontaneous reaction and the reaction is not feasible. It means iodine cannot oxidize, bromide ions cannot oxidize bromide ions to bromine. So that is the conclusion we have to give. Depending on upon the E cell, the spontaneity can be predicted and can be understood whether the reaction is feasible or not. So these are the non-metallic reactions that are going on. Next, let us see the other example. Find the cell potential of a galvanic cell based on the following reduction half reactions at 25 degrees centigrade. So at 25 degrees centigrade, there is a galvanic cell constructed, and it has cadmium ions with a concentration of 0.02 molar and lead ions with 0.2 molar. So they have also given us the data, like cadmium is undergoing, like it is accepting 2 electrons and giving cadmium. So this is like according to the electrochemical series. So the potential is minus 0.403 volt, and for lead it is minus 0.126. So what happens here, whenever there is a higher negative value, it is always lower for the lower negative value. So minus 0.403 is less than minus 0.126. So what is happening here? The potential of cadmium is very, very less than lead. So the cadmium potential, electrode potential is less. Therefore, cadmium is anode. Oxidation will take place. So at cadmium, oxidation will take place. That is increase in oxidation state. And at lead, reduction will take place and decrease in the oxidation state. And it acts as a cathode. So now we have to calculate the EMF so that we will understand the cell potential. So for cell potential, it is E cathode minus E anode. So whenever they are giving reactions like this, we have to first define what is cathode and what is anode. So what is cathode here? Cathode is lead. So we have to substitute the values, minus 0.126 minus of minus 0.403 volt, and we get E cell of 0.277 volt. So that is the reaction we get, and the potential is positive. E cell is positive. It indicates the reaction will take place. Next, let us see one example, like zinc wire is dipped in silver nitrate solution taken in a beaker A. So there is a beaker A. So here in this beaker A, there is silver nitrate. So silver nitrate solution is there. So what is happening here? Zinc is dipped. Zinc wire is dipped in silver nitrate solution. This is the silver nitrate solution. And a silver wire is dipped in zinc sulfate solution. So here in the beaker B, we have zinc sulfate solution. See, zinc sulfate solution in which silver wire is dipped. Silver wire is dipped in the zinc sulfate solution. Now what we have to do here? Predict in which beaker the ions present will get reduced. So we have to predict the reaction wherein the ions, whether the ZnSO4 will get reduced or AgNO3 will get reduced. We have to predict the reaction. So given that standard reduction potentials for zinc and silver are, for zinc it is minus 0.76 volt and for silver it is plus 0.80 volt. So now let us take the consideration of beaker A. So what is here? The zinc potential is very low. It is negative in negatively charged. So it is very low compared to silver. Zinc potential is low compared to silver. So a metal having lower reduction potential immersed into a solution, metal having higher reduction potential. So this is having higher reduction potential. So this is having lower reduction potential. Zinc is having lower reduction potential. So then what happens? This will get oxidized. So displacement reaction takes place. Therefore the zinc acts as anode. So this will act as anode and oxidation takes place. And obviously silver will act as cathode and reduction will take place. Whenever there is a reduction, the ions present will be reduced. Ions are reduced. That means Ag plus ions are converted to Ag. That is how the reaction will take place. And if we consider the beaker B, the silver potential is very high compared to zinc ions. The zinc ions present here is having very less potential compared to silver. Therefore, no displacement reaction will take place. So these are some of the understanding, like we have to understand depending on the electrode potential. Whenever they are giving electrode potentials, we have to predict whether there is a reduction reaction or displacement reaction taking place depending on their electrode potentials. Next comes like in the fuel cell, hydrazine. We have a hydrazine fuel cell wherein hydrazine is oxidized to nitrogen. Hydrazine is oxidized to nitrogen and oxygen is reduced to water. Here the hydrazine is oxidized to nitrogen and oxygen is reduced to water. So the electrode potentials for the reduction of nitrogen to hydrazine and of oxygen to water at 298 Kelvin are minus 1.155 V. Voltage, it is given in the voltage minus 1.155 voltage and plus 0.401 volt. So under what conditions? Under alkaline conditions. They have given clearly given that alkaline conditions are present. So it means excess of OH minus ions will be there. Hydroxyl ions will be there. So under alkaline condition. Now what we have to find out? Write a balanced equation for both the half cell reactions. Now we have to write the half cell reactions under alkaline conditions. So for the cell reaction where the hydrazine electrode is on the left, calculate the standard EMF of that cell at 298 Kelvin. So here the hydrazine N2H4 Under alkaline medium, see here OH minus ions indicates alkaline medium, that is converting to nitrogen and water and giving rise to 2 electrons. So that is having a potential of minus 1.155 volts. So this is like we have written a half cell reaction. This is half cell reaction. Other reaction is reduction of oxygen to water. So here the oxygen is taking up electrons and forming hydroxylase, that is nothing but again in the alkaline medium, like it is giving rise to alkaline medium, and it is having a potential of plus 0.401 volt. So what is happening here, we have to write the net cell reaction for this. So whenever we write net cell reaction, these 2 electrons and 2 electrons get cancelled, and this also get cancelled. We will have 2 H2O here. We will have 2 H2O here, and this forms the anode wherein the oxidation is taking place. Oxidation, it is given very clearly here. The hydrogen is oxidized to nitrogen. It means here the oxidation is taking place and it forms an anode. Here it is given very clearly, reduction is taking place and it is a cathode. Reduction is taking place and this forms the cathode. So the net cell reaction is hydrogen plus water, oxygen is giving rise to nitrogen and water. So this oxygen is reduced to water, hydrogen is oxidized to nitrogen. This is the net reaction. Net reaction. So now we have to find out the EMF. So we have completed the first part of the question, like we have written the balance equation and the net cell reaction, and now find out the standard EMF of the cell. So E cathode minus E anode will give the cell potential, so that we have to substitute the cathode plus 0.401 minus of minus 1.155 volt. So we will get a potential of 1.556 volts. So this is the E cell, like 1.556 volt. So this is the standard EMF for that particular fuel cell. So next is the calculate the standard cell potentials of galvanic cell in which following reactions takes place. So they have given a reaction, net reaction is given. This is the net reaction. Net reaction they gave. What is happening here? The chromium ions is oxidizing to trivalent chromium. So trivalent chromium. So oxidation happens. Oxidation, increase in the oxidation state, and the cadmium plus 2 ions is reducing to cadmium. So this is reduction. And they have given the electrode potentials for this chromium at like minus 0.74 volt, and for the cadmium it is minus 0.40 volt. So now we have to write the equation, like chromium is converting to chromium, trivalent chromium. So this is an aqueous and 2 electrons are liberated, and the cadmium is reduced to cadmium. That is like 2 electrons get cancelled, and we have to get the final net reaction as per the question that is present. So now we will calculate the E cell for that. So calculate the cell electrode potentials. Like E cell we have to calculate. Now we know what is anode and what is cathode. Now here is the oxidation. So this is the anode. For example, we will write here, it is very clear, like this is anode and this is cathode. So now substitute the values here, like cathode and anode electrode potentials, like minus 0.40 cathode, minus 0.40 minus of minus 0.74 volt, that will give a cell potential of plus 0.34. So whenever there is positive sign, it indicates spontaneous reaction, and the reaction is feasible. So next, calculate the cell potentials of a galvanic cell in which following reactions takes place, like iron silver combination, wherein iron plus 2 ions is converting to iron plus 3. So what is happening here? Oxidation, increase in the oxidation state, and Ag plus ions converting to Ag. So reduction is taking place. Reduction is taking place. They have given the electrode potential for silver plus 0.80 volt and for iron plus 0.77 volt. So same thing we have written in the half cell reaction. Half cell reaction, like Fe plus 2 is converting to Fe plus 3 and 2 electrons, and then Ag plus and 2 electrons giving rise to Ag. So we get a net reaction of E cell. We have to calculate. So E cell, so actually this is like only one electron is required. We will be multiplying with 2. So we will get 2 Ag and 2 Ag. So this is the whole reaction, and the E cell is calculated. What are they asking for? The EMF of that particular cell. So for the E cell, E cathode minus E anode. What is the cathode here? Oxidation is anode. Oxidation is happening. So this is the anode and this is the cathode. So we have to substitute the silver potential plus 0.80 minus of plus 0.77 volt, and we get a value of minus 0.03 volt. So this is negative in charge, negative, non-spontaneous reaction, and reaction is not feasible. Not feasible. Reaction is not feasible. So whenever we are applying for any applications, like we have to take into consideration the potential of that particular cell, so that we will understand whether that will work or not. So next is find the EMF of the cell, represented by the diagram, cell diagram, like zinc to Zn2 plus with the standard hydrogen electrode. Standard hydrogen electrode is given. So here zinc is oxidizing to Zn2 plus. So if we see here, given that oxidation potential of zinc to Zn2 plus is plus 0.7618. So what is the standard potential? Standard potential for hydrogen, it is 0. So we have to consider it as 0. So we will substitute same in the equation. E cell is equal to potential for the electrode zinc and potential for the hydrogen electrode. So oxidation potentials we have to substitute. So here plus 0.7618 minus 0 volt, because hydrogen is having 0. So it is having the 0 electrode potential, therefore we have to substitute 0 and we get same answer like plus 0.7618. So this is like estimation of or determination of, we use this reaction generally in determination of reduction or oxidation potentials of reduction potentials or oxidation potentials of unknown electrodes, of unknown ionic solution. It means we have, for example, we have here zinc, but we may also have silver here. Whenever there is silver ion present here, it is nothing but the potential, that is because this is 0. So the potential whatever we get in that experiment is nothing but because of the silver or the zinc ions present. So this can be used in the finding out the potential for that particular ions that are present in that particular experiment. Next is predict if the reaction between the following is feasible. So we have to know whether the reaction is possible or not. So iron plus 3 ferric ions and iodide, given the reduction potentials are standard, potentials are like Fe plus 3 to plus 2, it is plus 0.77 volt, and for half reaction like I2 to I, it is iodine to iodide, it is plus 0.541 volt. So we have to know whether this reaction is feasible or not. So upon writing the reaction like ferric ions and iodide, it will give rise to ferrous ions and iodine gas is liberated. So now this is the overall cell notation. Overall cell notation, this is the cell notation. This is the salt bridge that is present between both the cells. and then this is the change in state. Like from gas it is forming ions, aqueous media. So it is similarly in this case also, it is both in aqueous media only, and platinum is the electrode. So now we will find the cell potential for that particular cell. So it is given by E ferric ions to ferrous ions minus potential for the iodine to iodide. So we have to substitute the values that are given. So plus 0.77 minus of plus 0.54 volt, and we get plus 0.23. So the reaction is feasible and spontaneous. So generally it should be greater than 1 for any spontaneous reaction. So it is like the reaction, we can only just say that reaction is feasible because the cell potential is positive. Next, find the EMF of the cell based on the following reduction half cell reactions at 25 degrees centigrade. So they have given a silver electrode and thallium. So silver Ag plus and electron give rise to Ag, that is the reduction, and that is plus 0.80 volt, and thallium it is minus 0.34. These are from the electrochemical series that are given. So both cannot be reduction, so it is from the electrochemical series. So we have to write down the complete reaction. So here the Ag plus ions and thallium is giving rise to oxidizing the thallium to thallium plus and reduction to Ag. So that is nothing but silver. So here what is happening? Reduction, and here oxidation. So oxidation, anode, reduction, cathode. So now we will find out the cell potential, that is E cathode minus E anode, and we will substitute the equation like the values given in the question, plus 0.80 minus of minus 0.34 volt, and we get a cell potential of plus 1.14. It is like feasible reaction will take place, feasible reaction, and is spontaneous. So whenever there is a positive value that we are obtaining, the reaction is feasible. The reaction can take place and it is spontaneous in nature. It means as soon as we connect, there is the probability is like the reaction can take place. So the potential is also very important. So the potential out of this is very good, like it is plus 1.14 volt when compared to the previous examples, like we got around 0.23 volt. So whenever it is greater than 1, it is like the reaction is spontaneous. As soon as we connect the cell, the oxidation reactions and the reduction reactions will take place, and it will give rise to some voltage or current. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.